morning, students. So today we are going to discuss about our second unit, digital signal, advanced signal processor. So the first topic is digital signal processor. So before that, let us have a small recap of the previous unit, microprocessor. Okay. So what are the main components of main blocks of microprocessor 8086? General purpose registers, yes. General purpose registers. It is a 16-bit microprocessor. Okay. What about memory? 1 MB microprocessor. Okay. Then there is a ALU unit and there is a separate queue for pipeline. So today we are going to discuss digital signal processor. So it is mainly designed for processing the digital signals. Okay. Can anybody say where it is used, digital signal processor in a real-time application?
Digital image processing, audio signal system.
Audio signal, very good. Audio signal processing system. So in our CD recordings, okay, we hear songs from CD and DVD. So it is this voice signal is converted into electrical signal and then it is converted into digital form. Okay. So digital signal processor is a signal processor and it is a special type of microprocessor. So already in the last unit we have studied about the basics of microprocessor. Okay. So it is a special type of microprocessor which is fabricated on metal oxide semiconductor integrated circuit. So this is also a IC. So it is also an integrated IC. So all the things that is arithmetic and logical and ADC, all these things are integrated and designed as a single IC. Okay. The main application of digital signal processors are it is mainly used for digital image processing, telecommunication, audio signal processing, and speech recognition system. So before that, next slide. So before that, we should know what is ADC and what is DAC. What is ADC? What is DAC? Can anybody define what is analog, what is digital? What is analog?
Waveform.
Is a continuous signal. Continuous with respect to continuous signal with respect to time. So it is continuously variable signal. Okay. So what is digital? Okay. So this is the basic block diagram of DSP. That is the input side microphone is present. Okay. So the microphone, the voice signal is that is the sensor. Okay. What is meant by sensor? Sensors are used to convert physical quantity into electrical. So here our physical signal is our voice and it is converted into electrical, or so microphone is used to convert our voice signal into electrical or current. That is electrical signal, that is voltage or current, and then it is given to signal condition. Here the signal is filtered and after that here we are using anti-aliasing filter so to remove the noise and it is given to analog to digital converter and again it is given to the digital signal processor to process the given analog signal and again it is given to digital to analog converter and in the final stage also we are using filter. Okay, and then it is then converted into that is the output side is loudspeaker. Okay, so this is the main block diagram of. So here the main processes we are using sensors. Okay, so the main input of the digital signal is it is mainly used for physical signals. That is what are the physical signals? Voice, light, pressure, velocity. Okay, so next. So there are three types of digital signal architectures. That is, first one is von Neumann architecture and Hardvard architecture, and then super Hardvard architecture. So this is the block diagram. So in this von Neumann architecture of a digital signal processor, it includes a single memory and single bus. Okay, so the CPU shares a common memory for data and instructions. Okay, and Kumar is going to summarize the points.
In today's class, we discussed about the digital signal processor. Digital signal processor is a special type of microprocessor which is fabricated on metal oxide semiconductor and integrated circuits. And this digital signal processor has different applications like speech recognition system, sonar, radar, telecommunication, etc. And we have seen the block diagram. It consists of analog to digital converter and digital to analog converter. It helps us to remove the unwanted noise and we get a proper.
So in the input side and output side we are using filters. It is used to remove unwanted noise. Okay, filters are mainly used in the digital signal processes.
After that we saw architecture. It consists of three architecture: von Neumann architecture, Hardvard architecture, and super Hardvard architecture. Von Neumann architecture consists of common memory and common bus for both data and instructions. And Hardvard architecture is a little bit upgraded architecture. It has a separate memory and data access for data and instructions. And super Hardvard as architecture consists of program memory, data memory, and RAM memory access.
Okay, very good. Kumar.
Today we are going to discuss about the three architectures of the DSP. First one is von Neumann architecture, Hardvard architecture, and super Hardvard. In von Neumann architecture, there is only one memory for data and program. The CPU has two buses, one for address bus and data bus. And the other architecture is Hardvard architecture. Unlike the von Neumann architecture, the Hardvard architecture has two memories. One for program memory and data memory. It has two data bus and two address bus. So access the program memory and address memory at the same time. Next we are going to discuss about the super Hardvard architecture. It has same as the Hardvard architecture. It has both program memory and data memory, and it has additionally it has cache memory and data memory access. Direct memory.
Additional memory is cache memory, and there is a separate another controller, that is DMA. What is DMA?
With this DMA, the input output devices can directly access the memory without the interruption of CPU.